Hey ChemExcel. All right, this is your little refresher video on calorimetry. We're going to do a final temperature calculation one, and I will go ahead and go through the algebra. And you'll get to hear the full thought process because I have not gone through this problem yet. So you'll get to hear it in real time in terms of going through that too. All right, so here's the problem I made up. We got 50 grams of imagininium, okay, at 60 degrees Celsius is added to 100 grams of imagininium at negative 15 degrees Celsius. Calculate the final temperature of the system. All right, so we know every calorimetry problem is going to start with a graph. So go ahead, make our graph, we'll access time. All right, and if we take a look at our temperature range here, we're going from one is at 60 and one is at negative 15, and those are both between the melting and boiling points. So we're going to be a liquid, all right, for both samples of it. So one's going to start at 60, and it's going to be cooling down. One's going to be starting at negative 15, and it'll be warming up, and we don't know, in this case, what temperature they're going to meet at. All right, if it had given us a final temperature, we will be able to actually put a number here for TF, but in this case, it did not. All right, these are both going to be liquids in this case. All right, it's based on melting and boiling points, and we're within that range. When you set up the calculation, since we have two temperature changes, we're going to have an MC delta T equals MC delta T, and we're going to cancel our negative, right? We want to make sure that we keep one substance all over here, the other substance on the other side. All right, so for our first one, we'll just go with the 50 grams at 60 degrees Celsius. So we have 50 grams. The C value for the liquid, it's given over here, all right, is 2 calories per gram degrees Celsius. And then the 50 grams, or we could even label it over here, this is the 50 grams, is dropping in temperature. It's going from 60 down to TF. So we're going to do TF minus 60 degrees Celsius. Okay, we will go ahead and throw our negative out front right now so we can't forget about it. All right, the mass of the other sample, it's the same substance, all right, but other sample is 100 grams. Same substance, so it has the same specific heat. Right, we know a lot of other calorimetry problems, maybe you don't know the specific heat of that other substance, you just write a C here in that case. And then we have TF minus negative 115. Yes, I'm going to leave it like that. All right, sorry to those of you who don't like that. All right, that's how we set that up. It's really just about keeping track of making sure that everything that's cooling goes on one side, everything that's warming goes on the other side. All right, and that you don't have some weird mix and match situation going on. All right, for those of you who have been having some questions about the algebra, all right, first let's start by just multiplying these out front. So here we've got negative 100, 50 times 2, right? TF minus 60. Notice I'm going to ignore the units right now. You can go through with it with all the units, but I wouldn't recommend it in this case. All right, over here we've got 100 times 2. 200 TF minus negative 15, all right. All right, I'll go ahead and just change that to a plus at this point. Okay, distributive property. All right, so we've got 100 times 60. I think I'm doing that right. Phone shut off, calculator's not up. Whoops, we don't need that parenthesis anymore. Okay, I don't know what 200 times 15 offhand is. 3,000. Probably should be able to figure that one out now that I stop and think about it. Okay. All right. Good for you guys out there who were like, it's 3,000, Mrs. Heath. All right. Next, we're going to group like terms. I would like to get this negative out of here, so I'm going to add it to the other side. And then I'll get this over to the other side, subtract it. Right, so now we've got 6,000 minus 3,000 over here is 3,000. And then we've got 300 TF. All right, and so our TF should be 10 degrees Celsius. right? Nice thing about these problems is that you can always go back and double check your work if you want to, right? So this would be just plugging in numbers, 50 times 2 times 10 minus 60 equals 100 times 2 times 10 plus 15, and we can just double check that. Not like that. Okay, sorry, 50 times 2 times 50 gives us 5,000. All right, and then the other side of that, we have 100 times 2 times 25 is 5,000. Right, so it works out. Right, once you get your answer, you can double check to make sure that your work